Q of 1, 1, 0, 1, 1. This would be Q of 1 times Q of 1 given 1 times Q of, excuse me, let me write this down explicitly. Q of x1, x2, x3, x4, x5 is equal to 1, 1, 0, 1, 1. This would be equal to Q of x1 equals 1, and Q of x2 equals 1 given x1 equals 1, times Q of x3 equals 0, given x1, x2 equals 1, 1. Times Q x4 equals 1, given x1, x2, x3 equals x1, x2, x3 equals 1, 1, 0. Times Q of x5 equals 1, given x1, x2, x3, x4 equals 1, 1, 0, 1. So Qx1 equals 1, we've already established this is 1/2. Q of, so let me write down the equation. Q of xn equals 1, given x1, x2, and so on up to xn. Excuse me, xn plus 1 equals 1, given x1 to xn is kn plus 1 divided by n plus 2. So what is this? This is probably kx equals x2 equals 1, given x1 equals 1. So now n is equal to 1. So my denominator is 3. And my numerator is what? The numerator is 2. xn, x1 is the number of 1s in the sequence from x1 to x1. A single element here. That's a single 1. Over here, now I have qx3 equals 0. Well, I know qx3 equals, well, what I do is I basically take 1 minus whatever the solution I get from here. Now n is equal to 2, so my denominator is 4. And my numerator, what's the number of 1s? It's 2, so therefore my numerator is 3. x4 equals 1, given all of that. Now n is 3, so my denominator is 5. And kn, k3, is now 2, so my numerator is 3. Over here I have x5 is 1, given these values x1 to x4, so n is 4, the denominator is 6. The numerator is, kn is 3. 3 plus 1 is 4. So if I perform this subtraction, I get 1/2 times 2/3 times 1/4 times 3/5 times 4/6. That cancels with that. That cancels with that. That cancels with that. And I get 1/30. Now, one thing you could do is get a calculator. You could take the root of that, see if you can figure out what you effectively excuse me, that's not right. This is something like p to the fourth times 1 minus p. We have 1 0 here and 4 1s. So this would be telling this, if you could solve this for p, that would tell you what this thing thought the probability of a single one was. Now, let's see something else interesting. What if we do this? I'll leave that up. What do you think the probability of that sequence will be? Or the Q value? I think it'll be 1/30th. I actually haven't worked this out, but I think it'll be 1/30th. The reason is, this is exactly the same sequence except all the bits are reversed. So if we're counting, remember the probability for 0 turned out to be counting the number of zeros. So we should end up with the same flavor of problem, except it's just that the symbols are reversed. It should make no difference because we're not really assigning any importance to the symbols because we don't know what the probabilities are in advance. So qx1 equals 1, qx1 equals 0, qx2 equals 0 given x1 equals 0, qx3 equals 0, excuse me, qx3 equals 1, and x1, x2 equals 0, 0, qx4 equals 0, given x1, x2, x3 is equal to 0, 0, 1, and qx5 equals 0, given x1, x2, x3, x4 equals 0, 0, 1, 0. Okay, qx1 is 1/2, qx2 is 0, so I have to do this, 1 minus qx2 equals 1, given x1 is 0, kn is clearly 0, n is 1, so that's 1 minus 1/3. x3 equals 1, given x1, x2 equals 0, 0. So kn, n is 2, kn is 0. So that's 1 over 4. x4 is 0, so I have to do this. 1 minus, now n is 3, denominator is 5. The numerator is kn, k3 is 1 plus 1 is 2. And x5, 0, so I have to do 1 minus. N is 4, the denominator is 6, and the numerator is k4, which is 1 plus 1 is 2. So this ends up being 1/2 times 2/3 times 1/4 times 3/5 times 4 over 6, which is exactly the sequence I had before. 1 over 30. So basically what we're fundamentally doing is we're doing something like counting the number of zeros and ones and calculating the probabilities based on that. So the assumed probability of this sequence should naturally be the same as if I had 1, 1, 0, 1, 1. Okay, now what we're going to do is we're going to form the arithmetic code based on Q.